Okay, so we're looking now at definite integrals. So we're going to be using what we learnt in the fundamental theorem of calculus and actually getting some questions done. So previously you've calculated indefinite integrals. So for instance, the integral of x plus 2 dx, x turns into x squared on 2, add 1 to the power, divide by the power, 2 the constant turns into 2x, and then you just add c because we don't know. There's not enough information. There could have been something that derived to 0, so we just don't know. So we call these indefinite, and we always put a plus c. So now we're given boundaries. Okay, so we're given boundaries for the integral. So the integral of fx dx from a to b equals the substitution of the top number minus the substitution of the bottom number, where the fx, capital Fx, equals the integral of fx. So what does it mean? So looking at the same question as the first page, we've got numbers 2 and 5. So now we integrate x plus 2 like we did before, but this time we have square brackets and we put the boundary numbers. Okay, so we put the numbers 5 and 2, we put them on top, and again, this is the technique. You have square brackets for the first part. And then when you make the substitution, then you turn it into curved brackets. So where the x is, you put 5, so you've got 5 squared on 2 plus 2 times 5. You always minus, and then you sub in the second number 2, where x is. So you end up with straight calculator skills, 22.5 minus 6. I don't think I made a mistake. So the answer is 16.5. And there are no units. The definite integral has no units, so don't worry about that. So copy that down. Let's have a look at the second example. Integral 2 minus x squared between 1 and minus 2. So we've got a power, so we add 1 to the power, divide by the power, and we also divide by the derivative of the bracket, which is minus 1. Now this time there's a number 1 on top, so this number 1 and minus 3, I'm going to take that out because that's a constant, and let's just get rid of it and we'll multiply at the end. You can do that with numbers, you can't do it with letters, but with numbers you can move the numbers out the front. So then we've just got 2 minus x cubed that we sub in. So when I put in x equals 1, 2 minus 1 is 1, and when I put in minus 2, 2 minus 2 is 4, so 1 cubed is 1, 4 cubed is 64, so I get minus 63, but I'm minusing by minus a third, so I get 63 over 3, which is 21, so the answer is just 21. Okay, copy that down. When you're ready, come to the next slide. So, definite integrals can be negative. Okay, they don't always have to be positive, and definite integrals are not areas under curves unless the question asks us to find areas. So that'll be a future video. So at this stage, you can have negatives and they are not areas. Okay, so variation to the style of question that you could be given. So you might be missing one of the numbers on the integral sign, so we just do our integral. So 8x turns into 8x squared over 2. 2 into 8 goes 4, so I bring the 4 out the front. So then we've just got x squared from k to 0 equals 36. And by coincidence, 4 goes into 36 9 times. Then I substitute the k and the 0, so I get k squared minus 0 squared equals 9. K squared equals 9. So we can get plus or minus 3. So at this stage, there's an algebraic solution that's 2. At this stage, there's no rule that says you can't have a smaller number on the top. Okay, so at this stage, there are 2 solutions. And there's an exercise to do. There's a lot in that exercise 9e, but most of them are exponentials and logs and trig, so we won't be doing that yet. So I hope you enjoyed that very short video, and I'll see you another time.